from histopathological images using recurrent neural network. I welcome the technical session chair, Dr. Mohammad, Kamrul Hussain from University, the University of
today is that I want to start with
from Malaysia.
research and development
Welcome, sir.
So the research project is completely
now you start your presentation.
Running out of
Sir, shall I start, sir?
Yes,
Monika, so you can always see all the.
Please enable your video, the presenter, the general instruction for all the participants. Out of 15 minutes, 10 minutes for presentation, 5 minutes for question answer session. So those who are going to present, kindly enable your video till the presentation ends. Okay, ma, go ahead.
Yes, sir. Good morning, everyone present here. Myself, Monika, a full-time research scholar from Puducherry Technological University. My topic is detection of breast tumor from histopathological images using recurrent neural network. I am working under the guidance of Dr. G. Nagarajan sir, Professor, Department of ECE, Puducherry Technological University, and my co-authors are Dr. ASHISH BAGWARI sir and Dr. G. Nagarajan sir. And these are my presentation outline. Introduction, biomedical image processing, literature survey, motivation of work, proposed work, results, summary of work done, and key references. Prologue, biomedical. As we all know, biomedical is the most trending field in the modern world. The main aim of the biomedical is to improve the healthcare by developing the engineering solutions and accessing, diagnosing, and treating various medical conditions. Image processing. Image processing is includes the analysis, enhancement, and display of images captured via various imaging techniques such as X-ray, CT, computer tomography, magnetic resonance image, tomographic images, and histopathological images. Here, tumor, as we all know, tumor is the mass of abnormal tissue. A large number of abnormal tissue grow together in our body. It's a leading cause of death worldwide. Here I have taken a breast cancer. Breast cancer is the most commonly occurred cancer in women, rarely in men. It's occur in a different type of age groups. It occur when breast cells mutate and grow out of control, creating of a mass of tissues. Like other cancer, breast cancer also invade and grow into the tissue surrounding your breast. These are the symptoms of breast cancer, and these are the breast cancer staging. In stage 0, it's a non-invasive tumor. It's a greater than 2 centimeter, but it do not have the potential to spread to the other parts of the body. Stage 1 is an invasive tumor, is a less than 2 centimeter tumor. Then stage 2 is a tumor around 2 to 5 centimeter, and stage 3 is greater than 5 centimeter. Then stage 4 is the tumor spread to other organs. And this is the overall view of the breast histopathological image staging. Patient statistics of tumor. Here we can able to know breast cancer is the most common cancer in third one. It's the third place. Then these are my literature survey. First paper deals with the detection of breast cancer from whole slide histopathological images using deep multiple instance CNN. Here a whole slide images has taken and a convolutional neural network is used. Here a small number of patches are from WSA images are extracted by a trained pathology, and deep multiple instant learning based CNN framework is used. Second one is sampling based tumor recognition in whole slide histology image with deep learning approaches. Here a computer aided diagnosis system is used to obtain the WSA images. Then third paper deals with the classification and diagnosis of invasive ductal carcinoma. This is also one of the breast tumor. Here a convolutional neural network is used. Then fourth paper deals with the quantitative whole slide assessment of tumor infiltrating CD8 positive lymphocytes, ER positive breast cancer. Here tumor infiltrating lymphocytes from white blood cells, estrogen positive breast cancer is relation to the infiltrate outcome to relate to the immune modulatory mechanism. Then fifth paper is antibody supervised training of a deep learning based algorithm for leukocyte segmentation, HI image styles. Hemoth paper deals with the metallic image based subclassification of lung cancer. Here, a multi-layer perceptron convolutional neural networks such as SqueezeNet, VGG16 and VGG19 are used. The main my motivation is main existing approaches uses the individual level annotation, but here I'm used the bag level annotation to separate those images from the whole slide imaging. Deep learning algorithm is one of the tremendous is making a tremendous process in the pathology analysis for detecting the image segmentation, identification, metastatic detection, such as my proposed work is benign and malignant tumor classification by MobileNet algorithm using recurrent neural network architecture. These are my proposed work. First, detection and classification of tumor images has done. Then future extraction using recurrent neural network for the WSA image, whole slide image, training and testing of Breakers datasets using MobileNet algorithm, and obtaining the results of Breakers datasets. This is the block diagram of proposed work. First, a data set has been taken, then it has been undergone a training and testing image. After in training, pre-processing has done with the MobileNet algorithm, then testing also done. My proposed work deals with totally 39,545 images. Then the data sets are undergoing testing, training, and validation. Here, recurrent neural network was constructed and the training was performed. After that, algorithm is loaded using a MobileNet algorithm. Deep learning algorithm has shown a greater promise in pathology image analysis for automatic detection and classification of image analysis. Then neural network is nothing but several interconnected processing elements of neuron that connect one to another through the connection in different layers, various layers of networks. RNN is a recurrent neural network, is a image captioning model consisting of encoder and decoder. Here, from the encoder, the important features from the images are first extracted. From the extracted images, those features as the input, and the decoder takes those features as the input and them used to generate the caption. Here, for the encoder, the pre-trained network MobileNet algorithm is used as a encoder for the recurrent neural network. This is the architecture of recurrent neural network: input layer, hidden layer, and output layer. RNN is the image captioning model. Compared to CNN and other networks, RNN will give a memory power. This is the architecture of the MobileNet. Here in MobileNet, depth-wise separable convolution is used. Depth-wise separable convolution is nothing but compared to the other convolutional, depth-wise separable convolution is used as a single convolutional filter for each input channel. In other architecture, they had used a multiple convolution for each input channel. The advantages of depth-wise convolutional filter is it is used with a fewer parameters and the time also reduced compared to other networks. Histopathology is the study of tissue and pathology is the study of diseases. Here, a model of the solitary fibrous tumor is given. That A denotes a 10x magnification of a benign tumor and 40x the magnification of the B denotes the 40x magnification of the malignant tumor. As of C denotes the 10x magnification of malignant tumor, 40x denotes the malignant tumor. Here, whole slide imaging is a scanning of convolutional glass slides in order to produce digital imaging. Here we can able to see from whole slide imaging, we can able to take the nodule region, tumor region, like that. This is the bag level representation from a whole slide images. First, we can take the patches from the healthy tissues and patches from the tumor tissues. Then both healthy tissues and tumor tissues are went into a bag level representation. From that, we can obtain a benign and malignant tumor. I have generated the confusion matrix. Confusion matrix is nothing but is used to obtain the performance of the classification. First one, 60 denotes the true positive, then 3 denotes the false negative, false positive, then true negative, true positive. This is the accuracy I got and loss. Comparison we can see the for the existing methods, my proposed work is compared. The accuracy is 3% increased and recall is 95.23 and specificity is 92.30. Precision is 95.23. I have also calculated the AUC ROC curve. It shows the how well the performance, the model performance is, how well the method is performed. I got the 0.94 of excellent value. Here, a depth-wise convolutional RNN to improve the future extraction of images. The AUC ROC curve I got is 0.94%. These are my key references.
Yes, continue your presentation.
Thank you, sir. Sir, that's all,
okay.
Sir.
You completed the presentation. Okay,
yes,
fine.
Sir.
Okay. Dear participants, any question from this presentation, you may ask now. Participants, you can interact with the presenter. If you have any queries, you can clarify with her.
Okay, Monica, I have a
Yes,
few
sir.
questions actually.
Yes, sir.
Are you doing the PhD or Masters?
PhD, sir.
PhD, okay, good.
Okay.
This work you've done a lot of effort, I can see that. But all of the contents you did not clear it properly. Okay, which data set you used? Which
Sir,
data set
break his
you used?
data set, sir. Breast histopathological image data set, sir.
Yeah, where did you get this data set?
Sir, in Kaggle data set, sir.
So you have to mention this, that you are using the Kaggle dataset, and you have to cite this. Okay.
Okay, sir.
And how many feature you are using from that dataset?
Okay, sir.
How many features you are using from the dataset?
Sir, totally 40,000 images, sir, I have taken.
No. How many features?
Did not get it, sir.
How many feature you are using from the dataset? Okay, if you see your model, the recurrent neural network, what new thing you consider in your model? Can you go back to your proposed model? Your proposed model, recurrent neural network, yeah. This is the block diagram of your proposed work.
Yes, sir.
So what special, I mean, what new thing you consider for your RNN?
Sir, actually, I have done first work in convolutional neural networks, sir.
Okay, so what's
so
new
I
here?
used comparison between CNN and RNN, sir.
Okay, but what is new thing here? Because we also have some work. Our student also done some work, and I see many other work. You already presented many existing work. And what new thing you consider in your model?
Sir, I have taken whole slide images, sir, for data sets.
What's the difference?
Sir, in many paper they have taken normal images, sir. So I have taken a whole slide images in my paper, sir.
No, this is the data processing, but what is the new thing in the model? What is your contribution to the model?
Sir, actually in every paper they have done up to accuracy. That's all, sir. I have done model performance also, sir. From confusion matrix, I have calculated the model performance, sir, for every networks.
Means that you did not propose anything. You just investigated, right? You just tested the performance.
Yes, sir. Yes, sir.
Yeah. I also want to know that how you get the better result from the existing work. I can see that your work performance is better, even precision is better. How you get this?
Yes, sir. Using that algorithm only, sir.
Which algorithm?
MobileNet algorithm.
They also use the MobileNet algorithm. How your work is getting better result? Specifically considering what particular thing that your algorithm makes for a good result. You have to know this all, okay?
Okay.
Go back to the receiver operating curve. Go to the ROC curve. ROC. Yeah, receiver operating curve.
Yes, sir.
More. ROC. Yeah. Go down.
Yes.
Yeah. Yeah, this one. So
Yes,
based on what you plot this performance?
Sir, I have taken a confusion matrix value, sir. I have calculated manually using the formula, sir.
Which formula?
Sir, from confusion matrix, true positive, true negative, false positive, false negative, I have taken those values, sir. From that value, I have calculated using AUC or OC performance, sir.
This is only yours. Why not you consider the other one, the existing work?
Sir, in existing work, they didn't done that model performance also. They have done up to accuracy precision only, sir.
No. It doesn't matter. When you consider your comparison, you are bringing new metric. You try to compare with the other work. Otherwise, how we know that you are, better than the others? You said that your precision is better, your accuracy is better, and then you show that your ROC is showing better. I can see that it's better performance.
Yes,
but
sir.
better means how much better? Compared to who? Compared to what? Your physical paper, okay? And
Yes,
whenever you write something, try to be specific on your contribution. Like, you don't need to show so many things. You don't need to consider so many the algorithms. Say only that I consider only this portion. This is my contribution. This is my new algorithm I consider for the model. That is appreciated. It's much appreciated for the conference. It's okay.
Okay.
You need to know that specifically where is your new contribution. Okay.
Okay, sir. Okay, sir.
And if you go to go to your data processing. Go to data processing. Data processing. I just want to tell you one important thing.
Okay, sir.
When you are using the human data, okay?
Okay,
because
sir.
this is a conference. After the conference, you are going to submit paper to journal. Okay, so this is required. You must know that the human-related data, you must need the ethical, the approval. So you are using the human data. Okay, so I don't know that where you're getting this data. You must have the ethical approval from your university or from your government. Okay, so you must have it. Otherwise, you can just have the research, but you cannot publish. Nowadays, we handle a lot of trouble, having the human-related data publication. Okay.
Okay.
So be careful about it. I can see that. Go to dataset. Dataset. Histopathy. That one.
Yes.
No, back. More back.
This one, sir?
Yeah, from here, okay?
Okay,
so
sir.
You are using some, solitary tumor, fibrous tumor, okay? So
yes, sir.
This is actually not imaginary research. It is a practical research, means that this kind of data is relevant to the human data, and this is actually concerned to the ethical body, okay? It doesn't matter where you work, it doesn't matter where you stay, but you must have this approval when you start research, okay? And before publication, you must submit that approval letter, okay? And beside this, when you work with the data set, okay, you must have the existing data set, what already you have it from the Kaggle, okay? For example, a Kaggle has, the a data set, maybe they have 40 features, okay? I ask you that how many features you are considering for your model, okay? So you need to know that how many feature you are using, okay? And then you may reduce or you may increase, okay, the features. Then you compare that what processing, and I saw that in somewhere you process the data. Data processing is something that you must handle this, the feature engineering. So you increase the feature, decrease the feature, and then that you can compare that what is the performance between using your model with the existing Kaggle, the performance, because the Kaggle, when they they publish their data set in the Kaggle, they have the performance already. If you see their paper, they have the performance with this data set. So you also need to compare those data set by your process data set, that by your model. For example, you are using the mobile net, so you compare these two with the existing Kaggle and your mobile net, the data model with your convolutional mobile net with your process data. Okay, for example, you can reduce the feature. Maybe you don't need too many features. Maybe you need only 20 features. Maybe you need only 15 features. So based on that, you limit your data set and then you compare it, and then you see the performance. Okay?
Okay, sir. Okay, sir.
Yeah, these were the gap in your paper. I hope you will, recover it for your upcoming publications.
Yes, sir. I'll try to incorporate all the things, sir.
Yeah.
Thank you
Thank
sir.
so much.
Thank you so much, sir.
That's all from me.
Okay, sir. Thank you, sir.
Dr. Manikanandan. Hello. Is there anyone have question? Anyone has the question? If not, then we can proceed to the next. Participant. Okay. And thank you, Monica, for presenting.
Thank you, sir. Thank you so much, sir.
Applause to Monica. Yeah.
Thank you, sir. Thank you for all the comments, sir. All the valuable comments. Okay. Thank you, sir.
So our next participant is, the title is Developing a Novel Architecture for Convolutional Neural Network Firewall, Anomaly Detection in Network Traffic, presenting by Ms. Asfiya, Shireen, Sheikh, Mukhtar, et al. Okay. Okay, so you can.
You can share your PPT.
Yes, sir. Sir, my presentation is visible?
Not yet.
Sir, my screen is visible?
Yes, proceed.
Good morning to all of the presented here. Myself, Asfiya, Shireen, Sheikh, Mukhtar. My research topic is developing a novel architecture for convolutional neural network firewall anomaly detection in network traffic. In this research proposed convolution network, we can study a convolution neural network for firewall anomaly detection. Basically, the firewall worked on the traditional rule-based approach. The rule-based approach is basically in which the rules are inbuilt, and according to that rules, the firewall's anomaly detection can be performed, in which we can filter the firewall traffic by the rule of predefined rules. In this research, we can develop a novel architecture by using a convolution neural network to detect the anomaly detection data in firewall by providing the intelligence to that network. We can develop a combined model or hybrid model by using a convolution neural network and LSTM. This is the contents of the presentation, in which we can first discuss the introduction of the presentation. In the introduction, we can first discuss the how this model will be useful for cyber threats, in which we can detect the potential anomalies which is detected in a firewall logs data. We can develop a novel architecture. The novel architecture firewall anomaly detection, that is basically the transformative solution
to the limitations of the traditional defense mechanism. The traditional defense mechanism is basically rely on the firewall rule-based approach, in which we can define our rules, and according to the rules, firewall anomaly are detected. But the traditional defense mechanism has certain limitation. It is not capable of capturing all the potential anomalies, and it is not the intelligence. We can provide the intelligence to the firewall system by using a basically machine learning and deep learning model. We can apply the 7 machine learning algorithm and the 3 deep learning algorithm to develop a model that is basically enhance the security capabilities of the firewall detection. We can integrate the machine learning model. We can incorporate the 7 machine learning model. This basically retrieve their strength, their enhancement, their advantages, and we have to provide the capability to enhance the anomaly detection process, as well as we can develop or we can include a deep learning model, in which we can integration of the 3 basic deep learning model. The first is the feed-forward neural network. The second is the CNN plus LSTM model, which is our proposed work, and the last is the neural network. By combining these 3 models into a one combined, we can retrieve the basically accuracy of that model by capturing the intrinsic pattern in a network traffic data, as well as we can provide the self-learning system to the firewall system, in which the firewall system is a traditional system in which the rules are defined. We can provide the intelligence to that system, and the system, this model or this mechanism is a self-learning system. By enhancing the machine learning model and deep learning model, we can develop such a model, such a novel model, in which the data anomalies or network traffic data is automatically learn or self-learn which data is anomalies or which data is a normal data. We can provide the intelligence to that model by combining of the different machine learning model and deep learning model. Objective of this proposed research is emphasis to enhance the security system, cyber security system, to capture the potential anomalies, and we can provide a defense strategy, defense mechanism to retrieve the and to categorize the what is the normal data and what is the traffic data. Literature review. These are the few paper we can refer to develop such model. The first paper is the data mining method using a deep learning for anomaly detection in a cloud computing, in which we can focus on we can analyze the traditional anomaly detection method in cloud computing suffer from low training, poor detection, and an unstable result. In the proposed paper, we can use a deep learning method for dimensional reduction and map reduce for parallel processing. It is that a result we can capture by accuracy improvement of the 10.3% and the 18.0% and 7.2 respectively. The another paper is a deep learning based anomaly traffic detection method in cloud computing, in which the existing intrusion detection method face the numbers of challenges, such as high dimension massive data with uneven class distribution in a cloud computing. The proposed method, which use the GRNN model to updating the data center and algorithm, and we can use the algorithm MFOA, enhancing the anomaly detection performance. The another paper is the local and deep feature based convolution neural framework for brain MRI anomaly detection, in which we can analyze the challenges of the brain tumor, proposed significance, and we can and in this paper we can study the 3 deep learning model and capture and combining the CNN model for improving the anomaly detection. The last is the anomaly detection for intrusion control system based on autoencoder. The autoencoder is basically used for the model is learn the normal pattern from traditional autoencoder by simultaneously predicting and reconstructing the input data and addressing the limitation of the either approach. Methodology, as I discussed earlier, we can develop a model by the use of the different machine learning algorithm and deep learning algorithm. We can integrate the model by utilizing of the 7 machine learning models such as logistic regression, K-nearest classifier, Gaussian, NB linear SVC, random forest classifier, PCA random forest, and the 3 different deep learning models such as neural network, CNN, LSTM. It is a hybrid model and a feed-forward neural network. We can process a data set. We can use the data set by we can retrieve a data set in a cobble. And we can use a network intrusion detection data in which engaging a diverse data set capturing a regular and anomalies network behavior. We can categorize in this research. We can categorize the what is the how much of the regular data and how much of the anomalies data anomalies data is present in the data. Model performance evolution, we can retrieve the machine learning model, establish a baseline, and with deep learning models such as CNN and LSTM excel the capturing the intrinsic pattern from the data set. Model selection and refinement, we can identify a CNN and LSTM as an optimal model to find out the best based on the accuracy, FI score, precision, recall, and we can choose the model undergoes refinement to enhance the anomaly detection capabilities. And the last is a holistic methodology. Holistic methodology can identify enhancement of the robust CNN LSTM architecture to effectively handle the anomaly detection in a CNN firewall model. This is the proposed architecture of the CNN convolution neural network firewall anomaly detection, in which we can retrieve the data from the CSV file by CSV file, and we can perform the data processing operations such as data calling, data visualization, data splitting. After this process, the data goes on to the model which is basically use the 7 machine learning model and a 3 deep learning model. The 7 the machine learning model, logistic regression, KNN, Gaussian, NB, SPM, decision tree, random forest, and PCA, and that data is forwarded to the deep learning model, and we can find out the evolution, accuracy, FI score, recall, and precision. And this is the combined model. By using a machine learning and deep learning, we can calculate the accuracy, FI score, and precision, and we can compare with the existing model. Methodology, logistic regression is basically used for the binary classification. KNN, K-nearest neighbor, is a non-parametric model. It is basically suitable for the classification and regression tasks. Gaussian navifies assume independent features and Gaussian distribution. Linear SVC, support vector classifier, it construct a hyperplane to separate the classes in a high dimensional spaces. Similarly, we can combine the PCA and random forest integrated. The PCA with a random forest is used to reduce the dimensionality while maintaining a performance. Deep learning models, we can use the 3 deep learning model. First is the CNN and LSTM, second neural network, and third is the feed-forward neural network. CNN, LSTM, convolution neural network. We can combine the convolution neural network with a LSTM short-term memory, in which we can retrieve the numbers of different patterns from the data by the use of CNN, and we can combine with the LSTM to temporal dependency of the data and in a sequential data, and we can develop a hybrid model by using the CNN and LSTM. In a CNN to capture the spatial hierarchies and temporal dependency in a sequential data, it is basically extract the spatial characteristics, and while LSTM required to capture the temporal dependency. Neural network is inspired by the human brain, in which we have to process from the numbers of different layers. The first is the input layer, the second is the hidden layer, and third is the output layer, in which the human brain will be processed such that the neurons utilize activation functions and weight to analyze the data, and we can process the data by involving the assigning input through the network. The data will be processed by using of the neurons, and neurons have contained the weights function and activation function. Training involved adjusting weight or using optimization algorithm. We can also use the backpropagation algorithm to adjust the weight in a gradient efficiently. Feed forward neural network, feed forward neural network consists of comprising of the layers of nodes forming a directed acyclic graph. That is, the process data in a unidirectional flow from input to output. Hence, each node is linked the subsequent layer to associated weight and determine the influences. Results. In this figure, we can retrieve the prototype data, or we can retrieve the data from the Cobble intrusion detection data, in which we can categorize the intrusion detection data or prototype data into the three different categories. The first is the TCP, the second is ICMP, and third is the UDP data. UTP data, in this whole data we can categorize, or we can identify the what is the rate of the normal data and what is the rate of the attack data. We can clearly indicate that 53% in a whole data, the 53% is a normal data and 47% is a attack data. We can identify by use of the proposed method. We can also design a confusion performance matrix, in which we can calculate a confusion matrix by the use of numbers of different machine learning model, such as logistic regression, k-nearest, Navi-Bayes, support vector, decision tree, and PCA, in which decision tree and random forest will be work better. Table performance matrix. We can analyze the performance.
Your slide not moving. Hello. Your slides are not moving.
My slides is not visible, sir.
And the slides are not moving.
Not moving. Okay.
Yeah.
So
I can see only methodology now.
The present slide is a model performance matrix.
Yeah, now okay.
Okay, so model performance matrix, we can calculate the performance of the numbers of different model on the base of training accuracy, test accuracy, training precision, and test precision, training recall, and test recall, in which decision tree and random forest have given a similar result. Training accuracy 99.99, test accuracy is 99.85, and here in a random forest 99.86. We can calculate the performance of the each and every machine learning model by this accuracy and precision table. Conclusion. On the proposed research work, we can integrate the machine learning and deep learning model to overcome the limitations of the conventional firewall system, in which the conventional firewall system is basically the rule-based approach, and by using this proposed research, we can provide the intelligence to the firewall system to automatically detect the anomalies in network traffic data, and provide the adaptive solution to effective defense system. In developing performance we can refine the firewall efficiency and provide the insights of integrating of the machine learning and deep learning in a cyber security applications. These are some references paper we can refer for developing architecture. Thank you, sir.
Thank you. Professor Koris.
The audience have any questions for this or any queries? Okay, so I want to ask a few things. If you can go to your methodology first. Methodology, can you open methodology? Yes.
Yes, sir.
In the methodology slide, yeah, we can see that it uses the 7 machine learning models. Okay, This
Yes,
is
sir.
just for the testing. This is just for the testing, right? This is all existing, right? The 7 machine learning model are existing work, not yours, right? You just tested.
Sorry, sir, I'm not understanding your question. This 7 learning
Means
model,
that you okay?
sir, this
You
7
just
learning,
tested.
yes, sir. We can just tested the 7 machine learning model for the accuracy of the model. We can just tested this model. This is the
Okay,
existing
good.
model we can use.
Yeah, I also
And
see that
and
you have some
then,
comparison. But
and
I want to ask you about the data set. Okay, so which data set you use for training the model?
sir, intrusion detection data set which is downloaded from the Google site. It's a prototype data set.
This data is developed by who?
Sorry,
This data is developed by Kaggle or any research group?
Google site, sir.
Kaggle, okay. Do you
Yes,
know
sir.
how many features are inside this data set? How many features?
There are the numbers of different features such as UDP type, uh, uh, TCP, TCP type, and ICMP. We can use in this data set we have 15 to 20. I think,
Features.
sir, features.
But you have to know exactly how many features, and then what attack you can detect. What type of attack you can detect specifically?
Specifically, we can detect the firewall
In
anomaly.
TCP, in TCP, in TCP, in
Sorry, sir.
TCP, yeah. In TCP, what TCP protocol? What type of attack you can detect?
What type of attack, sir? Any type of attack. It is the attack which is in the form of text, voice, images. We can give some.
How about the DOS? How about the
Sorry,
DOS, distributed DOS? Denial of service.
जी sir.
Denial of service. DOS, denial of service. Did you consider in your dataset the DOS? For example, in TCP protocol.
TCP, sir. We can TCP data set. Sir, I'm not getting your question. Sorry.
Did you analyze the dataset by yourself?
We can analyze or categorize the data set based on the data which is uh, which is generated by the use of firewall. Suppose we have the system. Suppose I have the system, and we can generate the numbers of different data in a firewall logs. We can consider that data. Numbers of user can be downloaded, or surfing the internet can generate the lots of data in a firewall logs. We can retrieve that data, and we can categorize that data.
So did you process anything from the existing dataset?
In the existing data set.
Yeah, whatever you received the dataset from Kaggle, did you process anything on top of it, on top of that?
We
No,
can.
right? You just use the existing dataset, right?
Yes, sir. We do not use
Okay.
existing data set. We
Okay.
can retrieve.
That's why I was asking you that did you go for dataset processing? If you go for dataset processing, you might know the specific attack on the specific protocol. Okay. Anyway, you later on you can analyze this one. But I have another query on your optimization algorithm. So what's the new on your optimization algorithm? What's the contribution?
What is the contribution? We can develop, sir.
The optimization algorithm, yes.
This is the architecture we can develop, sir, by using the convolution and the by using the convolution neural network and LSTM. This is my proposed work. This is the contribution of me towards the cybersecurity threat detection.
No,
In
no,
which
I'm
we can.
talking about the optimization algorithm.
Optimization algorithm.
Yeah, you mentioned some of the slides that you use optimization algorithm. Yeah, here. The previous slide, yeah, you mentioned that you use the optimization algorithm.
So this slide.
No. Go back. No. Below, you scroll down.
Scroll down.
Not here, not here. It should be in the methodology, not here, not here.
Methodology, yes, sir. So this
Here.
Yes,
Yes,
sir.
you said that using optimization algorithm. Which algorithm?
Optimized algorithm is CNN, sir. We can use for the pattern recognition. It is the optimization algorithm will combine with the LSTM.
No, normally actually we use part of algorithms, like if we tested PSO, we tested the genetic algorithms and other heuristic algorithms, and also some algorithms that we can test on the model using these optimization algorithms. But in your case, you did not mention that which optimization algorithm.
Okay, sir.
You get my point or not?
Yes, sir. I'm getting which optimization algorithm I used.
Yeah. Which one?
So we can basically.
I think you have to check later on, okay?
Yes, sir.
You check later on because these 2 points I query. First one is the data set, and second
Yes,
one is the optimization. So these two are very important for your study. You are the PhD student, right?
yes, sir.
Yeah. So you explore deeper and try to understand the data set first, okay? And
Yes, sir.
then you, whatever you model you design, you have to know each of the layers. You said that you're using the 3 layers: the input layer, hidden layer, and output layer. But if I ask you that how many layer using for the hidden layer, you also must know that how many layer you are using in the hidden layer. So you must know this one. After this presentation, you may go deeper and explore and ask yourself that what will be the the extended contribution for your PhD work. Okay.
Yes, sir.
Okay, that's all. Thank you so much for your presentation.
Thank you, sir.
Yeah, if anyone want to ask to Miss Asfiya, please ask.
Sir, shall we call the next presenter?
Yeah, sure. Yeah. Thank you so much.
Thank you, sir. Thank you, sir.
Yeah,
the next presenter, Mr. Rajesh, you share your PPT and start your presentation.
Good morning, sir.
Good morning, sir.
Myself, Rajesh Bambare. My presentation topic is multiple classification for motor imagery EEG signals using FBCSP and convolutional neural network. Myself, Rajesh Bambare, and my guide is Dr. Manish Jain. I'm doing my PhD at Mansoor University. I'm working in teaching profession since 1998 for last 26 years. I'm associated with Pune University, Prora Rural Engineering College, Loni. Now, considering my research, the low signal to noise ratio of motor imagery electroencephalogram signals presents difficulties for feature extraction and feature selections. So with the good classification accuracy. So even with the notable advancements made, multimodal motor imagery decoding remains unsatisfactory. So the spatio-temporal frequency characteristics of various MI were extracted here using filter bank common spatial pattern. So we have used FBCSP technique. the motor imagery EEG recognition model's effectiveness is highly impacted by EEG's operating frequency band. So main thing here is selection of EEG's operating frequency band. So majority of algorithms are selecting a very wide frequency band. So a potential approach for multi-subject EEG recognition is to use convolutional neural networks. So we are using here filter bank common spatial pattern and convolutional neural network to extract discriminative features from EEG signals of diverse frequency components. And here we have carried out the experiments on EEG dataset from brain-computer interface competition 3 dataset 3A that I have used for calculation purpose. So the performance attains, so mainly the metrics that are used are accuracy and Cohen kappa that I have calculated. It was on par with the top approach among the comparisons. The findings demonstrated that the FBCSP based CNN approach reduced computational complexity at an average classification accuracy of more than 85.48% and average kappa value of 0.81. So as a result, this algorithm is appropriate for motor imaginary brain computer interface and other domains such as rehabilitation. Now, motor imagery is the mental practice of physical motions without doing them. So it has been shown that imagine motions and actual moments produce identical brain activity. So brain computer interface is a device that converts these patterns of brain activity into messages or instructions for user friendly man-machine interpretations. Now, electroencephalography that we are using, EEG signals are used to capture brain activity by BCI. Motor imagery based, EEG based BCIs are used in several applications like text input systems, wheelchairs, rehabilitation devices for stroke patients, gaming devices for the construction of adaptive human-computer interfaces. Now, basic MI categories are MI EEG based brain computer interface system. Principally, it is using sensory motor rhythm SMR and SMR. It is an oscillating pattern in electrical brain signals that initiates in brain areas concerned with voluntary movements like planning, control, and execution. So mainly here we are concentrating on alpha, mu, and beta band. Alpha frequency is 8 to 12 hertz, obtained from inside the sensory motor section of the cerebral cortex, referred as a mu frequency, and the beta band 12 to 30 hertz frequency alterations are utilized to distinguish the task in process for the left hand, right hand categorization of mainly motor imagery tasks. The data set we have used brain computer BCI contest 33A. This study was made use of BCI competition 33A dataset. The Graz University of Technologies Laboratory of Brain Computer Interface is the source of this dataset. So here we are having 4 classes of 4-second motor imagery tasks like tongue movement, right hand, left hand, and foot. Here we are using 60 channels, 60 electrodes EEG is there. There are 60 trials per class, and basically this is 3 persons data. If you consider the problem description, the main thing was to find CSP features, common special pattern features for BCI 33A dataset. From this dataset, we have to identify 4 class motor imagery signals to achieve better accuracy for identification, classification, and to get better kappa value and to get highly interpretable model. That was the main purpose of the research. The main papers that are referred, like novel deep learning approach for classification of EEG, IEEE transactions, then Mortis Gross Ventrup, this was there, and this EEG signal, enhancing EEG signal in brain computer interface using wavelet transform. So the main problem with these, when I seen these reference papers, the main thing was the first thing they tried to find out the filters for calculating the features. So there was difficulty in interpretability. Second thing with the paper was based on the this wavelet coefficients, but the wavelets coefficients were unable to capture the full range of frequencies, spatial and temporal patterns for capturing these features. And another paper, the reference number 28 was there, where KL divergence framework was used there. but the main drawback of their paper was the computational complexity that was taken while calculating the features. This is the position of 60 EG electrodes that we are using for this getting this particular data set. This is figure 1, that is FBCSP based CNN. So here we are having multi-channel EEG. On this multi-channel EEG, we are applying bandpass filters of 4 Hz bandwidth, and this from 4 to 8 Hz, 8 to 12 Hz, like up to 30 to 36 Hz. So different bandpass filters that we are applying. So here we are using bandpass filters, and then from this, for each filter, we are getting this signals that we are passing through CSP. We are getting CSP value, common spatial patterns, for each filter, and these common spatial pattern values, there we are feeding to the CNN classifier. So we are having multi-channel EEG as the input there, then we are passing through bandpass filters, then we are getting spatial filters, and then this spatial frequencies that we are getting, features we are getting, that we are feeding to the FBCSP based CNN classifier, and which is generating the required class output. Now propose FBCSP based CNN method. So 8 filters, each with a bandwidth of 4 Hz, are used to bandpass filter the input data from the data set. The collected EEG samples are initially divided into several signals that are distinct to different spectrums. Now CNN receives the common spatial values that came from these filters and uses them to create the necessary features. So CNN is basically drawing those features and doing the classification for us into 4 groups. Now the supplied data is flattened into a one-dimensional array. Whatever the data is given into flattening layer, it transposes the pooling and convolutional layers output into a format that can be fed into the dense linked layers. So the model is extended with the fully linked dense layers, that is 64 units, and ReLU activation function. And the softmax activation function and a second dense layer with with 8 units are employed. So we are having initially a sequential model is there, conventional 1D filter with 32 size and kernel size 3 that we are using. So initially first we are using ReLU rectified linear unit activation function. The next step is using max pooling with size 2, and then we are using flattened layer. After that we are using dense 1 layer with size 64. Here I'm using ReLU activation, and dense 2 layer with size 8. Here I'm using softmax activation layer. 30 epochs we are using with batch size 32, and Cohen kappa that I'm getting here is 0.81. Here it is the comparison with other papers. So basically this is subject dependent accuracy that we are calculating. So K3, K6, L1, these are the 3 persons. So initially the 26 reference SVM and evolved filters, they were having average accuracy for these 3 persons like 68.69. Then SVM plus pre-computed features 61.18. And then RBFN, then KL divergence that you use 70.33, CSP and CNN and SCS 70.83, and for propose our method we are getting 85.48% accuracy, average accuracy, and Cohen kappa value of 0.81. This is the graphical representation. From that you can see that this is our proposed method where we are getting above 80% accuracy for all the 3 persons that for which we are calculating all these things. So if you see that the suggested approach was assessed using dataset comprising 4 MI classes, 3A, DCI competition. So it shows that in terms of classification accuracy, our method was on par with the best currently available method. And the FBCSP CNN method's future potential is improving its efficacy, interpretability, and performance, applicability across a range of disciplines, which will ultimately aid in the creation of more accessible and efficient brain-computer efficient technologies. So we are having the main advantages our interpretability and efficacy. Again, as compared with the other methods, we are able to reduce the complexity over here. And since complexity is reduced and we are able to draw better features using FBCSP, so this is the method which can efficiently apply for brain-computer interface technology. These are my references. Thank you, sir.
Thank you, sir, for your excellent presentation. Professor, can you interact with the presenter?
Yes, sir.
Professor Ashish, Professor Mohammad. Okay, Professor, what are the limitations you found on the existing methodology, and what are the novel approach you adopted in your proposed methods?
The initial one thing is that the existing technology was like using this wavelet coefficients, but they were not able to properly capture the complex spatial and temporal patterns. Another thing was designing the filters for this particular classification, but that were the Taylor data was not closely related, and it was resulting in overfitting. So again, the same problem was with the KL divergence was there. And so when we are using filter banks and common spatial this together with CNN. So initially we are applying filter banks, then we are applying CSP values. So double smoothing is over there. So with FB filter bank and CSP, we are able to avoid the overfitting. And again, we are applying different filters with the sliding window technology. So we are capturing more features with sliding window technology over here, and we are getting better features with sliding window technology and CNN. So we are able to have the model that is giving better interpretability as compared with the other technologies.
Okay, sir. And can you brief about implementation, or what type of tool or simulation tool you used for developing your ideas?
We have developed this code in Python. Again, initially we have developed this. We have applied the filter banks. We have applied the CSP coefficient techniques, and then we have developed the neural network model, CNN model, with different dense layers, deep learning technology.
Okay, sir. Fine. Thank you, sir. Thank you.
Thank you, sir.
The next presenter, Miss Asfiya Srivastava. Share your PPT. Asfiya, are you there? Miss Asfiya Srivastava, are you there? Okay. The next presenter, Praloy Biswas. Praloy Biswas.
Sir, am I audible, sir?
Yes, sir. Sir, you share your PPT and start your presentation, sir.
Okay, sir. Sir, actually, there's a bandwidth problem, so I can try to present. Let me know if you are not able to see my screen.
No, I can see you, sir. You share and share your PPT and start your presentation.
Okay. Please let me know if you are able to see my screen fully.
Yes, sir. Your screen is visible.
Sir, good morning, everybody here, and especially Ashish sir for giving me the opportunity. So it's the review paper. It's not something robust we have developed. It's mainly review paper and some proposed methodology we discussed, but we don't able to implement it fully because there is still work is pending. So what we are talking about here, review of multi-language sentiment analysis in healthcare. Healthcare is a special domain where we should taking special care, and particularly after COVID, healthcare is becoming truly critical domain. Multilingual sentiment is rapidly expanding healthcare, utilizing machine learning to identify emotions, sentiment expressed in multiple languages. These discipline field integrate continuously language, natural language processing healthcare information. It helps healthcare provider to better understand patient attitude, feedback, response, and overall satisfaction. Particularly into this world, it consists of recognize the emotion of states and concerned patient from the diverse linguistic background. Healthcare provider can provide care service by getting insight into the patient experience across languages. Example include analyzing patient reviews, social media posts, and other multilingual feedback, track mental health, and encourage better patient provider communication, better communication, and provide outcomes. So, sorry, my slide was not moving. I think actually this is the TOC table of contents. So we're talking about the introduction. We're talking about the review literature, then challenges, then current approach, then proposed methodology, then evaluation of strategies, then experimental result, mainly its analysis, and its then conclusion, then references. So I already explained the introduction part, why it's required. Now going to the review of literacy. So I'm not going each one by one, but most of the review of literacy is done, and we are seeing some here and there gaps. Mainly gaps are code switching. There are gaps regarding language, mainly low resource language ability. There is a gaps regarding the performance. So there is a gaps regarding to handle language sentiment expression. So there is a gap of either it's in the problem of low resource language, or it's the gap of proper sentiment analysis or proper context analysis. There's a gap we saw. So now we're talking about the challenges. So key challenges of multilingual sentiment analysis include the language diversity. The mainly problem is language here. So healthcare data can come from different patients across the globe, and so language diversity is the main challenge here. Domain specific vulnerability. Healthcare is a special domain, and that's developing lots. So when we are talking about other domains, there is a domain specific vulnerability. There are particularly words, whatever we are talking about, is different from other languages, other domains particularly. So context dependency, the sentiment expressed in the healthcare data heavily depends on the context, such as patient conditions, treatments, relationship between patient and healthcare provider. So code switching, multilingual individual often switch their languages, some conversation on text, marking different, making identify language and analyze the sentiment accurately. So then figurative language, healthcare data may contain figurative language such as some metaphors, idioms, cram that can be challenging to sentiment analysis. Lack of label data, obtaining the data from training sentiment analysis for multiple languages for a healthcare domain can be a really big challenge due to ethical barriers. So handling negation is the problem, because handling negation sentiment such as not feeling well can reserve the sentiment popularity, and can be handled carefully with the sentiment analysis model. Dealing with the misspelling and abbreviation, because healthcare data people are generally writing when we are talking to people, the patient cannot be too technically or too educated sometimes, so they can do some misspelling, they can write something in abbreviated statement. So that can be, whenever we're doing a sentiment analysis, we have to be more cautious whenever we're handling with the healthcare data. So handling implicit sentiment, as healthcare is something probably you are discussing previously, whenever you're discussing healthcare, there's a permissions, government rules, regulations. So handling the implicit sentiments is the biggest challenge for healthcare data. So cultural and regional variations also varies, because for Indian people, what we are thinking, for other countries people are whatever they are thinking, even for within India, what people are thinking from different region to different region varies. So when we are talking to, suppose for people when we are staying in a village, for them some things maybe not good if you're telling them that that's you can die tomorrow. But if you're telling this thing to a person who is highly educated, then you can understand that the die possibility is that he'll be asking the question that how can I delay that die? But if you ask the question, you can die, poor people or basically villagers, they can shout. So you have to identify this, what is the, how we can express our fears, how to understand their voice. All the things is very much necessary for cultural and regional variance. Privacy is obviously a highest importance thing and ethical concern. So for other domain, you can take the data, but without as you are dealing with the human health, privacy and ethical concern need to be very is the highest concern here. So now we're talking about the multimodal development. It's obviously a challenge in the healthcare because developing a sentiment analysis model that can handle multiple languages in multi domains, that's the problem. Another things is extending the model because it's as it's a multi-domain, multi-language model. So as country to country, the scenario change, language change, healthcare disease change, pattern of healthcare disease change. So extending the model to a particular country or within a country, a specific region may be a challenge. So real-time analysis sometimes is a challenge because you are not getting real-time data due to ethical, maybe legal boundaries, maybe ethical boundaries. So current approach, what we are mostly working on, transfer learning. So leveraging a pre-trained language model like BART, expert BART, MBART, and fine-tuning the healthcare specific data in multiple languages to adapt model and domain languages. Then second, we are talking about the cross-language embedding. So using the cross-language word embedding such as most and lasers, we can capture the sentiment of the language and embedding the different multi-language sentiment analysis. Then we are talking about machine translation. Machine translation in the healthcare text to a high as languages such as applying existing sentiment analysis model. So machine translation, whenever we're talking some Bengali or Hindi, or so we have to transfer this thing machine to some high level languages for the data source is more. I'm not talking about high level language means C or Java. It's basically what the data source will be giving more. So that model is basically multi machine translation should be done. Code switching, developing a specialized model to technique handle code switching in healthcare data, where patients are provided provide a switch between language within a same text. So multitask learning, we're talking about the multitask learning, training a sentiment analysis model jointly multiple languages and tasks such as name entirely recognition and relation extraction and leverages representation to improve the performance. Data and the data acquisition generate the specific healthcare data in multiple languages such as technique but back translation and machine translation to increase the ability of training data. Domain adaptation, adapting the general purpose sentiment analysis model to healthcare domain by fine-tuning the domain specific data using technique like domain adversarial training. Now talking about the assembly method, combining the prediction to multiple sentiment analysis during different language and different technique to improve the overall performance. Intercapability techniques such as attention to visualize, model restriction to improve the transparency and extendability to multilingual sentiment analysis model in healthcare. Context aware model, so developing a model that can incorporate contextual information such as patient history, treatment details, providing notes to improve the sentiment analysis accuracy for the healthcare settings. About the ethical and privacy consideration, implementing a robust de-identification and de-identification, because talking about this here, we have to mask. If you can use the data, you can use the data, but you have to mask properly the sparse PI data. You have to identify what is PI data and what is normal data. If it is some PI data, you have to properly mask and you have to make it some general data. That is the thing we are talking about, the ethical and privacy consideration, because that is too much necessary for healthcare especially. I'm not talking about other domain, but healthcare. Suppose I have some critical disease and people may use this data for any research purpose, but they should not disclose my name, or they should not know my names and identification. So PI data should be transferred to normal data. Evaluation and benchmarking, creating a multiple language, a multi-care healthcare sentiment analysis data set, benchmarking to develop evaluation new models and technique, collaborate efforts. So encouraging collaborate effort between healthcare organization, research institute, technologies, shares data, and so here because we have to take data from different sources, doctor review,
I think your slide is not moving. What is the current slide title?
10.
Okay, you proceed, and you can give more detail about your proposed methodology and the implementation details.
Okay. So now give me time to go to the 10th slide. So proposed methodology, we are talking about the data collection and pre-processing. So for data collection and pre-processing, we have done some technique. So first, I understand that you people have a question about the how we are getting the data. So we are getting the data from different sources, not from single sources. I am telling you, but the maximum data we are getting it for multi-mode sentiment model. There is a multi model name I'm talking about. It's a multi-sentiment model. There is a called made multi-cent model. This has been we can download it from internet. That's available. GitHub, from GitHub actually I have downloaded it. Maybe from different sources people can download it. So in the data set there is a we are currently considering only few languages like English, Spanish, Germanese, Chinese. So in data sources are mainly we are using the data, so taking the data model, and then we are basically expanding the data model, basically training the data model using the online doctor reviews, social media posts, healthcare issues, medical different discussion from the medical teams. We are basically training the model. Now it's currently containing more or less 50,000 doctor reviews from English, 30,000 tweets from distinguished healthcare, 20,000 posts we consider, 15,000 hospital review we consider, and 25,000 social media comments we consider to create the data set, for training the data set. So for animation, that's any text animated in sentiment like positive, negative, neutral by speaker and medical professionals, we done it. So total size we consider more or less 1.40 lakh across 5 languages. Potential users we consider here, that potential training model we used for healthcare is the potential training the model using sentiment analysis of healthcare domain, analysis across different across healthcare, and benchmarking using NLP sentiments. So that's actually we have done it for data set collection. Now we are talking about the cross languaging. We are doing some modeling for the cross languaging for normal methods for news and lesser, and we are just doing it for our using our data set. So we are talking about the transfer learning, then the domain adaptation is nothing new. So we are talking about the health branch, and then we are talking about the continuous learning development. Now it's a collaboration and sharing. We are done with the collaboration sharing. We proposed a new model that's basically a multi-model hybrid model. So what's new here? Previously, we are either talking about some semantic lexicon-based approach, or machine like or SVM, or native bias, or CNN, LSM, that's deep learning, or transfer model. But we are not considering a single model. Rather, we are considering as a hybrid model. It's a multi-model multi-mode hybrid model, because we are talking about multi-languages, and for with a single language also we have to do it multi-model. So we are considering the hybrid multimodal approach. So now we are talking about the dataset creation. Is the evaluation strategy of this proposed model: dataset creation, evaluation matrix, cost language evaluation, domain adaptation evaluation, interoperability and expandability, human evaluation, benchmarking, robust and generalist evaluation, continuous evaluation, and privacy evaluation. Now we're talking about the results. As I telling you, that it's not a new something we're doing. We are doing the more or less existing model, but we are just retuning it and using. We are basically applying it to the healthcare data and want to show some experimental result here. So the corpus is eventually distributed in 5-star rating, strongly negative, very positive, and we meaning the 20% of the star represent of the each languages. We start about 50, we given some 20,000, 5,000 review for each, like 5 languages tested, developing the treatment switch each, and we have trained the multimodal adaptive database to evaluate the accuracy of proposed training system based on the review of the multi-language text analysis of the sentiment analysis. So how we are calculating the accuracy is basically calculation by this method, that is divided by sum of true positive, true negative, false positive, false negative, all those conditions we given, and we are considering the accuracy, precision, recall, F measure, sensitivity and specialty, and G-mean. Now if you talk, we try to use this for all those models that's currently available, or at least I can at this moment do. So we saw that XMLR current model is performing well rather than other model in our dataset. So conclusion is multimodal sentiment analysis, healthcare, rapid going togetherness, computation, linguistic, natural processing, healthcare are better and understand patient behavior, access to information. Major challenges include the lexicon gap between languages, semantic differences, cultural differences, and language. So current approaches employ technique like transferring language, pretend language, embed, and basically incorrect language into into model architecture. Potential healthcare application analyze the potential feedback, potential healthcare and unmet and patient provider in communication. Propose the model methodology combine the balancing domain of adaptations, semi-supervised learning based on migration and integrated models, and
okay. Okay, Pralay, excellent presentation, and only few queries. Can you brief about your implementation? What are the existing method used? How much percentage improved by using your proposed methodology? Can you show those the results?
Sir, this I am coming to this result, sir. This is the slide. Are you able to see it?
Yeah. So which one is your proposed methods?
Sir, here my proposed method is not giving 100% result here. So current, as per the current method, this is review paper. That XLR M still is giving some good result.
Okay. So yours review paper. Okay, fine. Okay.
Because my proposed method is yet not fully implemented, so I have just given a review on that.
Okay, fine. You stop sharing.
Stop sharing.
Miss Anila, can you share your PPT?
Yes, sir.
Hello, sir. Hello.
Yes. Tell me.
Sir, the next presentation is mine, no?
Yeah. I called you. Okay. So, Miss Anila, you may present next to the this presentation. Now, Mr. Samir and Ajani, you share your PPT.
Yes, sir.
Is the screen visible, sir?
Yeah. Your screen is visible. You can start your presentation.
My presentation is clear and visible. Voice is clear.
It's visible. You can proceed.
Yes, sir. Yes. Thank you, sir, for the reply. The work is an improved Q-learning model for enhancing the efficiency of assessing environment impacts of urban development using special multi-criteria analysis. The rapid pace of urbanization and infrastructure development has been made significant negative effect on the environment, including air and water quality, and there are many pollutions has been there. Evaluating this effect is now more important than ever for achieving sustainable urban development. There has been many methodologies created over the time for evaluating environmental effect, but the majority have been focused on the single criteria assessment. Nowadays what happens, due to the urbanization and the many infrastructure development, the urbanization creates the polluted in the environment, where there are many factors are there which is being polluted, like air and all. So it is very important to assess the impact of this. Now the problem is to deal with this problem. A special multi-criteria analysis approach that can simultaneously evaluate multiple criteria and their spatial distribution have been developed. This study assesses how urban development will impact on the environment using the spatial multi-criteria analysis approach. Along with the other tools like decision-making tools, we have various methodologies that are mentioned in the paper, like fuzzy, Electra, Promethi, APH, and many more that we have used for assessing the impact. The spatial distribution of various environmental indicators such as land use, water quality, air quality, habitat fragmentation can also be evaluated using this approach. In the decision making, the study indicates are explicitly specially mapped using GIS and remote sensing data before being weighted and evaluated using the 3 decision making tools that we have proposed in the paper. The integration of the different decision making tool enables a more thorough and reliable assessment of the environmental impacts of the urban development. With the number of indicators pointing in the direction, the study's finding help highlighting the significant negative effect and the urban development has been on the environment that is being the focus part of the paper. The result is also emphasized the importance of considering the range of variables and their spatial distribution in order to have a better understanding of how urban development impacts the environment. In the paper, we have proposed various methods that help for the finding of how the various factors can affect the environment and how we can assess these factors, and it will indicate how the impact has been made, and that can be used by the government and other agencies to go through it. This is the architecture where we have used various data set. Some of the data set are land data set, water quality data set, air quality data set, habitat we have data set. All these data are collected and integrated, and then there are decision making or decision methods are there, just like electric, Promethi, APH, and fuzzy techniques are there. All these are the decision making techniques. Some of the techniques are being proposed by the other researchers. I have used these methods, and the detailed description is available in the paper. That can be the results of this can be fused under the fusion decision. It may be some kind of the highest value can be used, and further that can be this decision can also be an optimized with some kind of evaluation, and the optimization has been performed on the parameters, and then again if required the process can be again be iterated till we not get the appropriate result. These are the data set, a land data set, air quality data set, water data set, and habitat data set. These all are the data set available on the government agencies, and some of the data set are also available in Kaggle, but that is not appropriate to use on. The most of the data set that we have used is the government data set. Is the electric method. All these parameter can also be, all the four data set can be assessed with the help of this method, and then the decision can be taken. The details I have not included in this presentation. The detail is available, the step-by-step algorithm is available in the paper. The Promethi is another technique where preference ranking organization method for enrichment evaluation. This is one of the technique which is again I'm using. This method is being proposed by some other researchers. Analytical hierarchical process. This is also an decision making process. The fourth one is a fuzzy logic based method. All these four methods are being used for the decision making. Here you can see in the here all these four are the decision making methods that can be fused together, and the final decision can be taken for the prediction. Then the Q-learning model is there. The Q-learning model and the methods for the details of Q-learning is available in the paper. This model is the combination of the different steps. Like first we have the four data set that requires, then we apply some decision making processes on the data set, and that can be fused into the model, and that can be further be optimized with the help of optimization methods, and later on that can be used by some other government agencies. This is the results that we have obtained right now. The proposed method giving the accuracy around 93% related to compare with the previous approach being proposed by the other researchers. In the concluding remark, in order to increase the accuracy, precision, recall, F1 AUC, and the speed of decision recommendations, the more detailed results are available in the paper. In the urban development scenario, this paper proposes a fusion-based method, which is related to the fusion techniques and the Q-learning for optimization. The proposed model being compared with the other techniques, and it is found that the some of the results has been good enough to evaluate. In the future, we can also have been deployed at the regions of various part and being evaluated by the government agencies. These are some of the references. Thank you.
Thank you, sir, for excellent presentation. Audience and participant, do you have any query? You can clarify now. Sir, what are the novel approach you adopted in your proposed methods? How much percentage it improved when compared to the existing methodologies?
In the novel, you can see we have incorporated some of the high accuracy already proposed methods. We have integrated multiple methods which are being already proposed by the other researchers. We try to integrate all these together into one packet, and that can be call it as a fusion of all these methods, and further the related proposed good optimization method we try to implement. Also, I have hide some of the details in this presentation because the entire project is already submitted to the one government agency which is under evaluation for funding. That's why I have hide some of the part from the presentation.
In the data set, are you fixed any percentage for a testing data set as well as training data set?
It's a standard, sir. 80-20, 80 for training and 20 for testing. It's a
Okay.
standard
So,
we have taken.
okay. In your experimental, you took 80-20. Am I correct, sir?
Yes, sir. Yes.
Okay. Okay. Thank you. That's it.
Which is actually the standard of the any ML and DL processing.
Okay, sir. Fine. That's it. Thank you.
Shall I
Yes.
stop sharing?
Yes, sir. You stop sharing.
Yes. Thank you so much, sir, for giving us a time.
Miss Anila, now you
Yes,
share
sir.
your PPT and start your presentation.
Yes, sir.
Shivya Sivastava, you are the next presenter. Be ready.
Okay, sir. Thank you. Okay. Shall I start, sir?
Yes, proceed.
Good morning to all. Myself, I am Anila, full-time research scholar from EC Department, Puducherry Technological University. I am doing my research under the guidance of Dr. G. Nagarajan, sir, Professor, Department of EC, Puducherry Technological University. My topic is low-light image enhancement using VGG60 pre-trained model by transfer learning method. My presentation outline is, I would like to give brief introduction about what is digital image processing, then what is a low light image and what are the techniques available for low light image enhancement, then why we are going for low light image enhancement. The next is literature survey, then motivation, objective of the proposed work. In proposed work, I am explaining what is VGG architecture, how we are proposing transfer learning method in it, and simulation results, a summary of work done, and selected references. My introduction is digital image processing deals with the processing and analysis of digital images using various algorithms and techniques. These are performed to improve the quality of digital images by extracting useful information from them, and we are manipulating those features to get a better results. Those steps are the digital image processing involves various steps. Those are image enhancement, restoration, segmentation, compression, and analysis. These steps can be performed with various techniques, that is filtering technique, Fourier analysis, wavelet transform, machine learning, and deep learning approaches. Digital image processing has various applications in medicine, astronomy, remote sensing, security, and entertainment. So what is a low light image? Those images which are captured in a low lighting condition are categorized as low light image. For low light image, the illumination value will be in between the range of 1 to 10 lux. So those low light images have several disadvantages. Those are increased noise, low contrast, reduced color accuracy, increased blur, limited details. If we are using these low light images for further applications, computer vision applications such as classification, image detection, and recognition and all, we won't get sufficient results. So in order to improve our results, we have to introduce low light image enhancement. So these are the examples of real-time low-light images, remote sensing images, larynx endoscopy image, it is a medical image, then night traffic monitoring image, and underwater images. So why we are going for low light image enhancement, I already told. So low light image enhancement techniques can be categorized into two different categories. That first one is traditional method, then second is learning based method. In traditional method, gamma transformation, histogram, Retinx theories come. In learning based method, machine learning and deep learning based methods are used. Nowadays, the researchers are using deep learning based methods involving Retinx theory also. In my paper also, I am going to introduce deep learning architecture along with Retinx theory. So gamma transformation is a traditional method. It is a nonlinear transformation which is transforms each pixel input to a new pixel by using this transformation equation. So we are getting enhanced image by using this nonlinear transformation equation. So histogram equalization in another traditional method which is commonly used for low light image enhancement. Here each pixel in that input image is transformed to a new pixel in the output image by using this given equation, where C of k is the cumulative distribution function of the input image, where that C of k cumulative distribution function is given in that given equation, and where P of k is the probability of occurrence of that particular intensity level of the input image. So the next is Retinx theory. As per the Retinx theory, each image is a combination of two components. One is reflectance component and another is an illumination component. As we are considering a low light image, the illumination component, that is L of xy, will be the low value. Our aim is to improve this L of xy value, and we are calculating R of xy. R of xy is the reflectance component. That reflectance component which holds the complete characteristics of the input image. So we are considering this R of xy will be the enhanced image, and our aim is to improve this illumination component, and we are calculating reflectance component as given in this equation. So my literature survey is, in my literature survey, first paper includes that gamma correction. It is a traditional method which used to pre-process the hazy images. This method is used to improve the global wise enhancement of the input image. And the second paper involves deep learning based method. It is an autoencoder and CNN combination. In this, yes sir.
Ma'am, you brief about literature review and you talk more about your proposed methodology. In what way you improved your proposed approach when compared to the existing thing.
Sure,
you
sir,
can
sure,
brief about this literature review, then you can move on to the proposed design.
Okay, sir. So this is second paper is about deep learning architecture. It is here autoencoder plus CNN architecture is used. Here also RECURRENT theory is used as the basic concept. In next paper is a application based paper. In this low light image semantic segmentation is performed in low light images by using cycle GAN approach. In cycle GAN is a deep learning architecture. Here cycle GAN approach is used to improve the quality of low light image. Then they are performing semantic segmentation. Next paper introduces transfer learning approaches. Transfer learning approaches, we are utilizing pre-trained model for here they are using for landing scene recognition method. Next paper is transfer learning and fine tuning for disease detection. Here also transfer learning approach is used. Actually transfer learning is we are utilizing the pre-trained model. Pre-trained model are already trained models. We are utilizing the trained parameters, trained hyperparameters of those models for our task. I took this next paper is dual autoencoder structure. It is a deep learning architecture based RECURRENT based paper. Here dual autoencoders are used to improve the illumination component of the input image. My motivation is CNN is the preferred deep learning model for image feature extraction. Since we are using more layers in CNN, they are able to get more features. But here I am introducing pre-trained model for feature extraction. Pre-trained models are already trained model with a large data set, so we can reuse the hyperparameters of the model. By transfer learning approach, we can fine-tune the model with more layers, and we can utilize the model for our task also. As per the RECURRENT theory, we are using to improve the illumination component of the input image. So my objective is to design and implement BGG16 pre-trained model using transfer learning method for low light image enhancement. This is the basic block diagram of the proposed work. Here input image is pre-processed by the gamma transformation. Actually gamma transformation is the traditional method for image enhancement. After pre-processing the input image, the illumination component is extracted. That illumination component is given to the trained model, trained fine-tuned BGG60 model. The BGG60 model is already trained with a pair of data set. They are able to get a modified illumination component. After getting modified illumination component, as per RECURRENT theory, the reflectance component is calculated. That will be the enhanced image, that is output image. So, as I already told, that illumination component is extracted from the input image. How the illumination component is extracted is, the concept we are taking is the maximum value of RGB will be the illumination of the particular image. But by this concept, we are extracting illumination component. After extracting illumination component, we are given to fine-tuned BGG60 architecture. This slide shows the BGG architecture as a feature extractor. Actually, BGG60 architecture is a popular CNN architecture which is designed for image classification and object recognition. I am utilizing BGG16 architecture as feature extractor only because the last layers, 3 fully connected layers are removed and only 13 convolution layers are considered, and we are added extra few layers, that is some convolution layer, convolution 2D transpose, and we are training those models again to get fine-tuned that model and again to get a modified illumination component. By this transfer learning method, we are freezing some early layers of BGG16 architecture and trained last 2-3 layers, and again added extra few layers for our task. So how much layer we added is 6 convolution layers, 2 convolution 2D transpose, 4 upsampling layers are added. This is clearly shown in this figure. The first figure shows the BGG60 feature extraction layers. This figure includes pre-trained layers. Pre-trained layers are already freezed layers, and some layers of BGG60 architectures involves in training process, and extra layers we added like this. The explanation is given. The detailed layers are given in the next figure. Up to cooling layer, the layers are freezed. Then 4 layers of last VGG16 feature extractor are used for training along with added layers. This is the fine-tuned VGG16 model. So for learning purpose, we are training the model, and we are testing the model also. For training purpose, we are taking training data set. Actually, I am handling Lowell data set. Lowell data set contains 500 image pairs. Among 500 image pairs, 485 images are used for training purpose and 15 images are used for testing purpose. Here, training data set undergoes pre-processing. Here for pre-processing, we are using gamma transformation. After pre-processing the data set, the illumination component of both the input image and output image, input-output combination is given to the model. Input image, illumination component of input image and output image is extracted and given to the VGG architecture. The model is learned in such a way that to generate modified illumination component from those input combination. After training the model is tested with tested data set. Actually, the Lowell data set contains 15 test images. Each image is given to the trained model in order to get the predicted illumination component. After getting predicted illumination component, by using Retinx theory, we are getting output image. Before that, we are post-processing the image by using gamma transformation also. In my study, I used ReLU and leaky ReLU as activation function. I compared the results with both ReLU and leaky ReLU. ReLU and leaky ReLU are activation functions. Leaky ReLU is an extension of ReLU activation function. For ReLU function, we are getting output from 0 to maximum. For leaky ReLU, we are getting that value from -infinity to infinity. So these are the simulation parameter. Since I am using the pre-trained model and I am freezing some layers of VGG16 architecture, some parameters are not involved for training. Those non-trainable parameters are given in the table, and trainable parameters are also given. This is the model loss curve. While during the training phase, the loss function we are using is MSE loss function, and optimizer is Adam optimizer. After training 50 epochs, we are getting training and validation loss like this. These are the simulation details. I used programming language. I written the language in Python, and data used is Lowell dataset. Platform I used is Google Colab. Activation function for ReLU and leaky ReLU. Learning rate is 0.01. Number of trainable convolution layer only 9 layers. Number of epochs 50 epochs, and training loss and validation loss is given. So measurable parameters are that the model is model performance is calculated with the measurable parameters PSNR, MSE, and SSIM. Peak signal to noise ratio is commonly used method to measure the quality of reconstructed image. The PSNR value is calculated by using this equation, where maximum is the maximum possible pixel value of the image, and MSE is the mean squared error between original image and reconstructed image. MSE is calculated from this equation, and SSIM is the structural similarity index, which is a metric used to measure the similarity between input image and enhanced image. So these are the output. I got the output of test image, enhanced output image. Since I told you Lowell dataset having 15 test images, so those for 15 test images, corresponding enhanced images given in this table. So these are the graphical representation of PSNR and SSIM value. For those 15 images, the PSNR value is calculated and SSIM is calculated. Finally, I compared my results with some existing papers. Here, proposed work with the ReLU, I got 31.18 dB of PSNR value, SSIM 0.98, MSE 61. With the leaky ReLU also somewhat improvement I got. So my summary is the fine-tuned VGG16 architecture is proposed for modifying illumination component. As per the Retinx theory, we are going to calculate modified enhanced image by using this modified illumination component. As we are using transfer learning method, we are utilizing pre-trained model for our work. First 10 convolution layers are frozen and added some layers, and we trained the last 3 layers of VGG16 model along with added 12 layers. The PSNR got improved to 31.18 dB. It shows the superiority of the pre-trained model for feature extraction. So these are my selected references. Thank you.
Okay, thank you. Nice presentation. Any question from audience end? Okay. So in your experiment, you used 2 activation function.
Yes, sir. Yes, sir. I have one question. If you allow, then I can.
Yes, sir. Yes, sir.
Yeah, sir. Thank you. First of all, the presentation was so good. Madam, can you show me
Thank you,
there
sir.
is simulation graph loss function? Please show me that PPT.
Is this, sir?
No, my earlier one, earlier one.
This
Yeah,
is, sir.
this one. Yes, yes, yes. Please make it full screen. So my query is here we have two graph, and this
Yes, sir.
bluish one is decreasing drastically, and later on it is moving constantly. So why it is happening this kind of curve? What is the reason?
Sir, actually, for 50 epochs, I trained the model. After some epoch, that lows will be very lows, very less compared to previous epoch. That is 0 to some 10. The lows will be very high. Then after some epochs, the lows will be very lesser. That is why the curve is more close to point after point 2. That point 2 to 0, it is very close only. Losses very less, difference 0.220 very less only. That is why that curve is like that.
No, my question is why this curve is happening. What's the reason? I am getting this loss is very less, but
Yes, sir.
I am asking about this is there is a band where after drastically change it is moving constantly. It is
Yes,
below
sir.
point 0.2. So why this curve is happening? Why this losses or why this banding is happening at this point? This is
At,
my question.
at that moment, that model is able to learn. That is that error will be loss will be very minimum, sir. That actually given data is paired data, low light input low light illumination value, illumination component, and normal illumination component is given to the model for learning. At that particular epoch, the model is able to learn in such a way that output will be equal to that of input. That is why we are getting low lows at after some epoch, sir.
Okay, ma'am. There is another slide. Please move ahead. Yeah, this one, yes,
Yes, sir.
PSNR. So there is my one submission or basically one suggestion. You
Yes,
have
sir.
mentioned in the X direction that is the PSNR. I think 11, 12, 14. What are these things? 11, 12, 13, 14
Sir,
up to 115.
yes, sir. Actually, in this graph, x-axis denotes different images, sir. In low data set, 15 test images are there. In 15 test images, sir, I carried out that testing, and for each images, what is the PSNR value is in Y direction, sir. The
Yes,
PSNR
yes.
is the
So my
blue value.
suggestion is you have to mention X direction
Yes,
is
sir.
showing this one, Y direction is showing this one, so that it will
Yes,
be
sir.
easier to an audience to understand. Okay, this much
Sure,
clear.
sir. Sure, sir. Sure, sir.
Yeah, yeah. Thank you very much, Manikanandan sir, for giving this opportunity. Sir, if you have any query, you can ask, or if
Ma'am,
participant
yes,
there,
sir.
Yes, sir.
Ma'am, you used two activation function. So what
Yes,
are the
sir. Yes, sir.
difference between these two things?
Sir, actually, we are preferring activation function for getting a non-linear output, sir. For leaky ReLU, we are getting that output in between minus infinity to infinity. For ReLU function, we are getting only between 0 and infinity. In order to get more values, we are preferring leaky ReLU than that of ReLU, sir. I just compiled that output with the two different activation functions, sir.
Or used any simulation tools? So you mentioned simulations.
Simulation, I wrote means program in Python, sir. I
Okay.
perform my language in Google Colab platform, sir.
Okay. Okay, ma'am. Fine.
Okay, sir. Thank you, sir.
Stop sharing. The last presenter, Miss Sivia, share your PPT.
Yeah, okay, sir. Give me a minute. Yes, hello, sir. Can you see my screen?
Yes, yes. Your screen is visible. You start your presentation.
Okay, sir. Okay, good morning, everybody. My review paper is based on a comparative analysis of FRAN and CRAN architectures for the next generation wireless network. I have done this review paper under the guidance of Dr. Krishma Arya. I'm currently doing full-time PhD from Indira Gandhi Delhi Technical University. Okay. These are my contents: introduction, comparative analysis, performance metrics, results, future scope, and references. So for the introduction, let's imagine a network with a busy highway system. Traditionally, managing this highway system requires manually adjusting lanes and traffics, lights at intersection, which is very slow and inefficient. So software-defined networking is like a new traffic system for the network. It separates the decision-making control panel and the data flow. Think of it as a central command center that can electronically adjust lanes and light across the entire network. This allows for faster and more flexible control of networks. So FRAN and CRAN are like the different highway expansion strategies that can be used with SDN. FRAN is like adding more traffic control centers in different zones of the highway systems, and CRAN is like a centralizing all traffic controller decisions in one mega center. Both FRANs and CRANs have their pros and cons. So I am using two analytic models, stochastic process and queuing method, and I'm using MATLAB for this research. This is the basic architecture for FRAN and CRAN structure. So you can see FRAN is a cellular network architecture designed to address the challenges of increasing network capacity and reducing latency in 5G and future mobile networks. You can see that this is the BBU pool. The BBU pool is a virtualized collection of baseband processing units. In traditional cellular networks, every baseband unit has its own dedicated BBU pool. Okay, and then you can see there are mobile devices, fog access points. Fog access points are the radio access points that is deployed at the network edge closer to the mobile devices. Fog access points handle some of the processing tasks that would normally be done by a traditional base station, such as filtering and forwarding signals. And then there are radios R1, R2, R3, as you can see. These depicts radio units which are physical radios that transmit and receive signals from the mobile devices. So the key benefits of FRAN architecture is that it can reduce latency by processing data closer to the user equipment. This is important for applications that requires real-time responsiveness, such as virtual reality and augmented reality. Okay, so you can see here like BBU pool are connected to multiple FAPs, and each FAP is connected to multiple RUs and mobile devices which are connected to the FAPs. Then the next one you can see, this is the FRAN CRAN architecture. There are these mobile devices transmitting and receiving signals through remote radio head RRH deployed at the network edge, similar to the traditional cellular networks. So the signal transport RRH handles basic signal processing like amplification and filtering. Then they forward the signal to the centralized BBU pool via hand bandwidth low latency transport, often like fiber optic cables. Then there is central processing unit. The BBU pool consists of a virtualized BBUs in the cloud, performs complex signal processing tasks like modulation, demodulation, and cell selection. Virtualization allows for dynamic allocations of processing powers across the network based on real-time demands. And then there is signal delivery. Once processed, the BBU pool transmits instruction back into the RRH. So RRH use these instructions to modulate the signal and transmit it back to the module devices. Okay, and this is my flow chart for the FRAN. As you can see, first we are initializing the FRAN controller and preparing to manage the BBUs and RRH. Then we are setting up the FRAN controllers. BBUs and RRH sends registration request to the FRAN controller, and the controller authenticates and authorizes BBUs and RRHs to ensure they are legitimate and permit to connect. So basically we are making a connection between them, and first we are checking that if they are legit and if we can connect through them. Then virtual connections are established between BBUs and RHS to facilitate communication and data transfer. So this is how basically the connection is done. Then we monitor the front haul performances and traffics, and if the front haul performance is below threshold, then if it's yes, then they trigger resource allocation adjustment, analyzes the pattern and how the resource can be utilized, in what way they can be utilized, and then we allocate the resources, and then we update the virtual connection and configurations. And if it's no, so then we'll check if SDNS controller is requested by this application. If it's no, then we'll terminate it. And if it's yes, then we'll receive the requirements. Then we'll analyze those requirements, and then we'll check how we can allocate these resources, and then we'll allocate them. And then we'll update the virtual connections and configurations, and then this will end. This is for the CRAN architecture. So for the first one is basic, like initiating, then setting up the CRAN controller. We will process RHS registration request. Then we'll again check we will authorize the RRH, and then we'll see if it's legit or not. Then we will be establishing virtual connections to the RRH. Then we will be monitoring the RRH performance and traffic, and then the same thing. Then we'll check the threshold. If it's yes, then we'll trigger resource adjustment, analyze the traffic pattern and resource utilization dynamically. Then we will be allocating the resources, adjusting when we have allocated the resources, we will check then we will adjust the virtual connections and configure RRH. Okay. Then there is the basic thing now, what we have done in this comparative analysis. We can see that we have used the key parameters as quantity of servers, users, tasks, arrival rates, and service rates. These are the things which we have taken in the consideration when we were constructing the model for comparing these both architectures. The first thing which we are taking is the response time. So the response time is like within the model examination is affected by the stochastic nature of task arrival and service durations. As you can see the first equation, it is the more sophisticated queuing model. We can see that W represents the average time, while N denotes the total number of tasks. The parameter I signifies the probability of the encountering task type. I reflects the likelihood of the occurrence in the overall task distribution. Furthermore, the WQ represents the average waiting time in the queue model, specifically for task type I, indicating the duration task of this type typically spends awaiting processings. Lastly, mu I denotes the service rate associated with task. This will basically tell us what are the response time and what is the speed it is taking from the services to reach or to in the network architecture. Then same is for the CPU utilization. These are the formulas which we have used to basically check the result and how like FRAN and CRAN are different from each other, and we have used MATLAB for this one. These are the values taken, different values taken for the stochastic model and queuing model. These were my results. As you can see, FRAN appears to have low CPU utilization but high memory utilization throughout the measure period. But in CRAN, it appears to have higher CPU utilization but lower memory utilization through the same period. So when we talk about them, so the ideal balance is the best scenario involves a balanced utilization of CPU and memory. If either is too high, performance issues can rise. So that typically we can see if both of them are in a more of a balanced way. For an application requires significant processing power, will need higher CPU utilization, and also they can demand a lot of memory. So from this we can also say that FRAN might be preferable for the latency sensitive applications due to possible low CPU usage, enabling faster processing closer to the user. And CRAN might be better for the high data transfer applications because of potentially lower memory usage, allowing for efficient data handling. And from the conclusion for the first figure, we can see that these images or these figures highlights the trade-off, and the optimal choice depends upon the what is the specific requirement. For my specific requirement which I have taken, in that FRAN was a little bit better than CRAN. Also, in the terms of scalability, energy efficiency, and availability and total cost, we can see FRAN is considered to be more scalable, and FRAN's virtualized BBU in the central pool can be easily scaled up or down to accommodate changed traffics by adding or removing processing units. If its traffic is more, we can add more processing units, and if it's less, we can decrease them. On CRAN is less scalable, as centralized BBU in CRAN requires careful planning and investment in high bandwidth transports between the BBU pool and the RRH. Scaling up the BBU pool or the transport network can be complex and expensive. For the availability, potential for higher availability with the redundancy built into BBU pool. If one BBU pool fails, then there is a backup for that. The tasks can shift there, and hence minimizing the downtime. However, for the CRAN, a single point of failure in the centralized BBU can be a very problematic thing, potentially causing widespread service distribution, because there is no backup in the CRAN one. For the energy efficiency, for the FRAN, FRAN is more energy efficient from the CRAN by processing data closer to the user at RRH, which are available.
What are the difference between these two queuing model, FRN and CRN?
Sir, basically, sir, architectural difference hai. There is architectural difference in them. in the CRAN, there is one centralized BBU pool, and FRAN may we also have the backup, as I have said previously. Like there are and the RRH are closely kept at the network edge, where it is closer to the mobile devices, from which what can happen, like there is the time would be saved, and it is comparatively the data which will be transferring from FAPs to the BBU pool would be comparatively, it would be faster.
Okay, proceed, fine.
So energy efficiency, as in both, we can, from these diagrams only we can see the energy efficiency. We are using more energy on this CRAN, but energy efficient is FRAN. Additionally, CRAN is less efficient. Centralized processing in CRAN requires significant power for the BBU pool. Additionally, the higher bandwidth transport network between the BBU pool and RRH consumes energy. And for the total cost, we can see total cost can be lower. It depends upon the scale deployment. So according to mine, my deployment which I have used, FRAN is comparatively using less cost by the CRAN. Okay, so this is this is future scope and discussion. The future trajectories for the FRAN and CRAN, these both are very much used in telecom trends and connectivity needs. It is essential to shape the future advancements of FRAN and CRAN, enhancing mobile communication and network architecture. And the basic traditional radio access network limitations were not enough capacity for growing network demands and less flexibility and efficiency. So what we can see from FRAN and CRAN is there is a centralized baseband processing for the better resources allocations and the lower cost. So top software also, when we are using software design network with them, it is helping us to programmable control, dynamic resource allocation, and network slicing. So by using FRAN and CRAN, we are improving the network performances and the enhancing the network intelligence and optimization. Like it is a self-optimization network. It can like if the traffic is more, it will increase the baseband units, so that we can easily allocate the memory. Okay, so the FRAN in the security way, it is easier to identify and address vulnerabilities. And the business model would be like we have new opportunities for the customized services. It can be like it is a seamless integration and potentially a low latency services we can also give. So the future of FRAN could be integration with 5G networks. We can also use AI and ML for proactive resource management. Focuses on security and privacies. And for the CRAN, it convergence with the edge computing for low latency applications like IoT, and energy efficient structures and green networkings, dynamic network slicing for the diverse use cases like AR and industrial automation. So this was my review paper for the comparison of FRAN and CRAN.
Okay. Conclude your presentation.
Yes, sir. I'm concluding only.
This was very important thing. Yeah, you are talking about the next generation wireless network, Already wireless network have limited memory, limited bandwidth, limited power capacity. How do you overcome all these issues?
Yes, sir. Actually, as you can see, we can have a BBU pool, and suppose there is a lot of network, which in lot of incoming network. What we can do is we can increase the RRH, so that, and we can use AI/ML, so that we can allocate the memory to all of them. It can be when we are using AI, so it can use, we can give me a second. We can easily use them, and it can automatically allocate the resources to the different RRH or RRUs, so that so can you get my point, or should I explain it once again?
Okay, fine. Thank you.
Okay.
So I hope that all the presenter completed your task. The paper ID 231, any authors are joined? Okay. So we will wind up the session. Thank you for your active participations. Now I will end the meeting.